awesome. So it's more than Flaky test today. I'm actually going to be talking about two stories. Two stories that I've covered, some of them the past 5.5 years, some just the past year. But let me go through a quick agenda first. So I'll introduce myself and my team and what we do at Fitbit/Google. I'll give you some background info about our infrastructure, the tools that we support, and then we're going to go into our two stories, the Flaky tests and migration. Migration's everybody's favorite, right? All right. So my name's Simona. I've been on the Fitbit Developer Productivity team for the past 5.5 years. For those who don't know, at the beginning of 2021, Fitbit was acquired by Google. So now we are part of the Google Devices team. Our team still supports Fitbit, so all of the talk from now on is really referring to specifically the Fitbit's code and workflows. So what do we own? Everything. So it sounds like an exaggeration, but we own a lot of tools that are around basically everything, the entire workflow that goes between writing your code, committing your code, all the way to deployments. So some of these tools include infrastructure. We actually own the infrastructure for Jenkins, binary repositories. Right now we're using Artifactory. We're moving to Artifact Registry, which is what I'm going to talk about later. And we own the source control, Bitbucket. We're recently moving into Google's Garrett. And then I've got more things. We own our own tools. Some are built internally, some are third-party. We've got code quality, which is SonarQube. We have build analysis by Gradle Enterprise, and you'll see it comes in really handy. The deployment automation standardization, that's an internal tool that we've built, trying to make it very easy for our engineers to go from that code to actually having things deployed in production. Flaky test reporting, which is a little bit integrated with Gradle Enterprise. We own a lot of Gradle plugins to help make things easier for our developers. And then also lots of Jenkins libraries. Jenkins doesn't. Who here has heard of Jenkins and uses Jenkins? Excellent. Pretty much everybody. So with Jenkins pipelines, you can write them on your own, or you can have some common code, some common libraries that makes it a little bit easier for folks to write their jobs. All right, so I've told you what we do, what we own, all the infrastructure, all of that stuff. Now let's talk about a little bit more details. We've got a lot of code at Fitbit. We've got Java, we've got Python, we've got Go, Node. We are, in theory, a monorepo company, and yet we have over 2,000 repositories. Yes, not exactly monorepo. But let's talk a little bit about the monorepo. The monorepo is supposed to focus on our Java backend services, all of our REST APIs. And just mentioned, mostly Java-based, lots of microservices. We have about 200 microservices in this monorepo. But we also have a monolith, which has been around for maybe, well, I've been here for 5.5 years. When I joined, we were saying, we're getting rid of it. We are starting with microservices. We will be done in 2 to 3 years. We're not done. I honestly don't know when we will be done. So hopefully soon. But let's talk about more details about our monorepo. We have over 2,000 Gradle projects in it. And when I say Gradle projects, I mean build.gradle files. In terms of actual projects, services, I already told you there are about 200 microservices, but a lot of other libraries go into it. In terms of tests, we have lots of tests, over 20K tests, unit tests, integration tests, component tests, automation tests, everything that you want. Custom-built Gradle plugins, over 40, that our teams use to make things a little bit easier to build their little projects. And of course, I've mentioned we have we have so many projects in this huge monorepo. When it comes to building, every time you have to make a change, you have to build all of these projects. That sounds pretty scary. And I think if we were going to do that every single time, it would probably take over 3 hours to build everything, which is not very reasonable. So we build our own internal tool called a build orchestrator. Basically determines, based on project dependencies, when you change your code, what should I be building, really? Do I really need to build everything, or do I just need to build these 2 little projects? It saves us a lot of time on builds, but we still have a few things that result in the whole monorepo having to build. And then when that happens, here come Flaky tests. So, I don't know if you've attended the previous talk, but what are Flaky tests? Flaky tests are tests that sometimes pass, sometimes fail, but you don't actually know why. You would expect them to really always pass, but they don't. So we've had this issue. It's probably everybody's bane of existence. We've had this issue for a long time. So ever since I joined, we had this nice little chat where everybody could come in, Slack channel, say, hey, my build's failing. Well, okay. Great. How can I help? Well, these tests are failing, but the code that I just changed has absolutely nothing to do with these tests. Why is my build failing? Well, go talk to the team who owns the tests. And the team says, well, I don't know why my test is failing. It should be passing. So we try the build again. We're like, OK, build your pull request again. Let's see what happens. Oh, it passed this time. Oh, well, that's not good. We had so many requests every single week. And that was basically what we spent most of our time on, is trying to debug, find out if these tests are flaky or not, and talk to the teams to fix them. It was very time consuming. We did not have a lot of time to work on our actual projects. So what are we going to do about it? Releases are blocked. Everybody's asking us. We're all spending time trying to figure things out. How many Flaky tests we have right now? I mean, it's been 5.5 years. We tried to do so many things, trying to reach out to the teams. We still have over 200 Flaky tests. So we really don't like it when builds are blocked. So what have we done? Before Gradle Enterprise, we built our own internal Flaky test detector. But here's how we did it. Our monorepo, we said it's over 2,000 projects. And OK, tests are failing. We need to somehow rerun these tests. But we're not sure if it's really the tests or there's something else in the infrastructure. So what we're going to do is we're going to rerun the build 3 times. And then find out if those tests, how those tests fared. But notice that I've said we are rebuilding the whole build 3 times. So everything takes 3 times as long. So while we were finally getting some reports and we knew which tests were flaky, that didn't really help us much when it came to developer productivity, because everything took 3 times longer. And here comes in Gradle Enterprise. Since then, we've been using the test retry plugin. So now whenever there's a test, we try them 3 times. But instead of running the entire build again, we're just running the tests. Speeds things up considerably, and we have really good data. All right, great. We have data. That's wonderful. Do you think people go and look at this data? Do they ever fix these? Nope. So we've had this tool for about a year and a half, actually more than a year and a half. But for a year and a half, we had this tool. Nobody ever fixed flaky tests. They were still a problem. And yes, we helped a little bit by doing the test retries. But we still had issues. So what are we going to do about it? Here's that nice little dashboard. Actually, this slide should have been removed. Anyways, so how are we going to tell people? Well, here's some issues. The Gradle Enterprise tool is amazing. It really helps you explore the test, figure out when did this start being flaky. How How long is it a big problem? What are the other tests that are faky or flaking in coordination with this test? Awesome tool. But again, people don't look at it. And also people don't know, wait, is this my test or is this some other team's test? So we had to actually make it very clear for our engineers that it is not enough to, we're not going to tell them, but they need to know. You, team, needs to know that you have flaky tests and you need to fix them. So we created a little small application that generates a report integrated with our owner system. So we took the data that Gradle Enterprise provides, and based on the test class names, we determined the owners. And then every week, we send out an email, and every 2 weeks, we have a basically engineering presentation that, in theory, all engineers should attend. And we put out a slide and say, hey, teams, you 3 teams, you've got a lot of flaky tests there. Please fix them. And of course, you're going to wonder, did this actually help? Somewhat. What we did see is an improvement in people's awareness. We've seen people saying, hey, I see that I have a problem. I'm going to create a ticket. Here is the ticket. So now we have a communication that, yes, somebody claimed responsibility, and they have tickets, and they're going to work on it eventually. But at least there's awareness. So now what? People have tickets. It's great. They're aware. But they still don't actually focus on it. So now being part of Google, we like to look at Google's processes. And one of the things that they have is this priority codes. Does anybody remember log4j? OK, funny story. I was on call. Log4j comes in. I get a notification on my watch. I'm also in the middle of a parkour class. I'm about to jump. And I get the notification on my watch. It says code red. I'm like, well, I don't know what code red is. I've never heard of it. I jump. I break my ankle. Actually, that is a very true story. Still haven't fully recovered. But I've learned about the code. So what are these code things? Code red, code yellow. This is something that the organization does, usually with support from directors, saying, we have a problem. We need to fix this. Depending on the gravity of the issue, so code red, everybody works nonstop until log4j is resolved. Huge security issue. Code yellow, we have a problem. We're going to continue working in our office hours, or working hours, on this until it's resolved and complete. So for our next steps, this is what we're doing. We're currently basically creating a code yellow and working on getting the director support. We're almost there. To spend several weeks, every single team will spend their working hours fixing those flaky tests. So hopefully, maybe by next year, I will have an answer on how that went. We hope that it works well. All right, that was my first story. Second story, repository migration. When I'm talking about binary repositories, I'm talking about whatever it is you're using to store your build artifacts. Docker images, jars, Python packages, you name it. Right now, we're using Artifactory. But of course, the question is, why are you migrating? How many people here have used Artifactory? OK. People use something else? Those who didn't raise their hands, OK. Maybe internal or external? You don't know. Does JetBrains have their own artifact repository type thing? OK. All right. Cool. All right. So in general, when it comes to migrations, what are the reasons you may want to migrate? That can be that the current tool that you're using is not very good. It can be because developers are complaining. Or sometimes it comes from decisions made by those higher up. For us, the reasons were twofold. One, we're part of Google now. So one of the requirements is we should try as much as possible to use internal or first-party tools. And if you really need to use a third-party tool, you have to really build your case. Now, how many people have heard of GCP's Artifact Registry? OK, Okay, a few. That's good. It's a pretty new product. Okay, I think it's got about a year. So last year when we joined Google, we weren't really considering it because it wasn't quite there yet. So let's go next. So one was we need to integrate. We have the option. Two, everything already that we own is in GCP. So this makes it easy from a security standpoint. We use the same IAM roles, very easy access. But there were some other things that we wanted to do with this. Since we're moving, and as we're thinking about designing and planning a migration, what should we take into account, right? So, okay, how many artifacts do we have? I'm not even going to do a count. It's probably in the millions. But let's just look at repositories. We've got 21 local repositories in Artifactory. Basically, that's where we store our internal things. 57 remote. So that are the repositories that connect to some external source, usually external dependencies. 13 virtual. Basically, the virtual repositories combine local and remote. Makes it a little bit easier to use. What else do you need to think about when it comes to a migration? Well, security. I don't know about your employers, but Google is very, very strict about security. We cannot just do anything we want. We need to go through a review process because we want to make sure that Google's data and our users have confidence in us that all the data that we own about them is safe and secure. So it's usually about a 2-month process to get approvals whenever you design something. OK, so those are the first two things. Now we need to talk about existing features, features that we use in Artifactory right now, and features that we would want to use in Artifact Registry, but maybe they don't exist yet. And there are still quite a few that don't exist yet. They will. But what do you do when you have a hard deadline and you need to move to a new product, but it doesn't have the features? Hence challenges. We'll talk about that. I put a little note here, making it self-service. So right now, the way we're monitoring Artifactory is we do everything, our team. We are basically the managers of it. We own the infrastructure. When it comes to somebody asking, hey, I need a new repository in Artifactory, they say, well, we say, OK, we'll create it for you. What do you need? Who do you want to have access to it? It's a lot of work on us. So we decided that with this wonderful opportunity of being integrated with GCP, we're going to make everything self-service. You want a repo? Great. Go click on this Jenkins job. It will create it for you. It will give you all the permissions you want. And we don't have to do anything, our team. So we made it easy for you, and we made it easy for us. But with every migration, there are challenges. So I mentioned Artifactory. As many of you know, it's been around for a while. It's a really good product. It's very feature-rich. And we are moving to Artifact Registry, which is also awesome, but it's new. It doesn't have quite every single feature that we need or that we're used to from Artifactory. So those are some challenges. Another challenge that we've had is, I've mentioned the feature problem. Well, we have to work closely with the Artifact Registry team itself and base our roadmap of migration with their roadmap of feature inclusion. And if Artifact Registry's roadmap is delayed, we have to get creative. So I'm going to cover a few challenges. So remote repositories. Artifactory already has them. Artifact Registry does as well. They currently, or at least for Maven, we're going to talk just about the Maven right now. They currently only support Maven Central. I've mentioned before that we have lots of external repositories or remote repositories. We are actually accessing 18 different repositories. So Maven Central is not enough for us. So we can either wait until everything's available, which is a possibility. But if the timeline gets constricted, we need to get creative. And that's when we start mirroring. So we're basically working on scripts to mirror what's currently in Artifactory or externally and putting them into Artifact Registry, at least temporarily until everything that we want is there. All right, challenge number 2. We use a lot of metadata on our artifacts. Here are some examples. We like to know who owns what. we know who owns the code, but you create artifacts and Docker images, and when you realize there's something wrong with it, or it's missing, or it's too big, or you've been storing them for the past 2 years and haven't been deleting them, who do you reach out to? Well, our owners' labels tell us that. Okay, I've mentioned that you've been keeping images for the past 2 years. That's a lot of storage to keep. So we need to be able to actually do some cleanups from time to time. But some teams really want certain things. Even though they're 2 years old, they don't want them removed. So we need to also tag them as do not ever delete. So now we have this challenge. We don't have tagging, or not tagging, but labeling metadata in an artifact registry yet. So we've requested the feature. It will get done. But in the meantime, we still need to support this. So our plan, of course, we're hoping that the artifact registry will do it before we have to actually do this, is to create our own service that is going to provide this metadata. Custom DB, just REST API. We're just going to do a simple database. Here's my image. Here's the path in artifact registry. And here's the metadata that I need associated with it. Oops. Challenge number 3. Well, that's all very nice and well when it's just you and your team migrating stuff. But everybody has code. 2,000 repositories, publishing or downloading things from Artifactory. Well, we have to get everybody to move. How easy do you think that is? Not easy. No, people don't want to do it. People don't read their emails. They seriously never read their emails. So we start easy. We document everything. We write scripts to automate as much of the things as possible. Some of the code, we give code examples. All people have to do is test. Just pick your project and everything you do, test to make sure everything runs smoothly and correctly. So we did that. We set a hard deadline. We sent out emails. We had announcements in our weekly or bi-weekly meetings. I was actually super impressed. For the teams for the monorepo, 75% actually tested. That's actually really impressive. But out of the teams owning all the other repos, so the 1,999, how many people tested those? 0. So I don't know what's happening there, but they're going to have to hurry up because Artifactory is going to be shut down soon. So speaking of Artifactory being shut down, we're going to do some brownouts. We're going to shut down Artifactory on purpose for a short period of time to just remind folks, you need to do this. It's a strategy. It actually works. When you don't read your email, force it. All right, so with any migration, things don't ever go smoothly. So we started out, there's multiple types of repositories, right? We started out with Maven. We started migrating. We pushed the code. The monorepo is there. It's set. I did mention people don't read their emails, right? Well, in order for your local machine to work with this, you need to authenticate with Google Cloud. There's a little script that you have to run. Pretty easy. But again, people didn't read their emails. The day after we merged the code, somewhere between 3 and 10 requests. My build isn't working. I can't download this. It's not working. Why am I getting 401s? Did you read your email? Here, go to the script. Here's the troubleshooting page. So that went actually pretty smoothly. But remember I said earlier, we have a monorepo. And in the monorepo, we have a monolith. The monolith is very, very complex. And even though technically I asked the team to test it, they tested only a little bit. They didn't go through their whole workflow. So the day after, they were trying to do a release of the monolith. It was failing. I'm like, OK, well, let's see what's going on. We'll help you out. We'll fix the issues. So we work with them closely. We submit more PRs to fix their issue. It looks like it's going well. And then it fails again. and then again. And then we're about 2 weeks in, and we're like, do we want to roll back? Do we want to continue trying to fix this? Because we don't know. We're playing whack-a-mole. I'm a little nervous at this point because we have a monorepo, so the master branch is not only our changes, but everybody else's changes. So now we have to cherry pick and figure out who's done anything related to this. And we have other repos that depend on the changes that we've made, and we really, really don't want to revert. So anyways, this incident it was a major incident. The monolith was not released for how long? Can you guess? Somebody guess. Sorry, what? No, not 5 years. That's a different story. That's a different story. It was a month. It was a month-long incident. We were actually ready on that last day of the incident to roll back. We had it ready. And somehow, miraculously, everything passed. So we didn't have to roll back. But, I was going to mention one thing. There's a mystery compilation errors. It's an interesting story. So one of the first failures, this thing that schema update job was failing, compilation error. What is going on? Like, this worked yesterday. Why is it failing? And usually when we have mystery compilation issues, and generally relate to third-party dependencies, it means that something changed. And we don't pin our versions, which is both good and bad. It turns out that when we introduced Artifact Registry and some of the Cradle plugins that come with it, we also introduced a new version of Guava. We went from Guava, maybe 18, something like that, to like 30 Android. That broke everything. So now that I'm thinking about it, I wish I had a screenshot. Gradle Enterprise came in really handy. You can actually compare 2 different builds. So we compared a build from a month ago to the current build, and you can actually compare the dependency versions. And that's when we noticed the Guava. It's like, oh, I bet you this breaks everything. So we pinned it. Everything works. So just letting you know about useful tools. All right, so we're sort of done with Maven. We had some interesting incidents. Hopefully we'll learn some things from it. But the show must go on. We've only migrated Maven. We still have Docker, Python, Go, Debian, 2,000 repositories. We still have to implement the workarounds that we mentioned to get things going. And the one big lesson out of all this is do not underestimate legacy code. You think it's easy, but it just nips you in the backside. Thank you. And if anybody has questions?